Hi guys. Today we're going to be talking about derivatives of inverse trig functions. And these formulas that I'm giving you, yes, need to be memorized. They do show up on the AP exam. There is no reference sheet for the AP exam. And while I have very minimal control over what you do for my unit tests, the ultimate goal in this class is to take the AP exam and do well on it. So, cheating now is not doing anybody any good. Okay, so as hateful as that sounds, that's where we're at. If you were cheating your way through these units, then what's the point in being in the class? Okay, if that upsets anyone and you have questions, please feel free to email me about it. But continuing on here. So these empty boxes, imagine those are your u's. So inverse sine of u would be 1 over the square root of 1 minus whatever u is squared times the derivative of u. This piece here is like your u prime, okay? Same with each of these formulas. Inverse tangent of u would be 1 over 1 plus u squared times whatever the derivative of u with respect to x is, so on and so forth, okay? So, inverse sine of x squared. First, I have to decide what my u is. Then, what is my fu? And now I'm going to use my formula for the derivative of the inverse of sine, which says 1 over the square root of 1 minus u squared. I multiply my u prime and my f prime of u together. And then I have to manipulate fractions, roots, all of that business. So this would be like 2x over 1. And then I multiply straight across. And can we go ahead and do this? X squared squared is x to the 4th. So this problem is as far as I can go. Okay. Number 2, same idea. We got to decide what we want u to be and fu. So u in this case would be e to the x plus 1. Fu is then going to be inverse cotangent of u. And then just like the past lesson, we're going to do derivative of each. So u prime is e to the x. Inverse cotangent of u, I'm going to use my formula. Then we multiply these u prime times f prime of u. Now, as nice as this answer looks, we can do more. We can actually FOIL out this set of parentheses and find a little bit more simplified denominator. So that means I'm taking e to the x plus 1 times itself. E to the x times e to the x, e to the 2x, e to the x times 1, another e to the x times 1 is a 2 e to the x plus 1. And then I combine like terms. Okay. Number 3, an inverse secant. Again, I have to decide what my u and my fu are. I'm using the formula up above. Sorry, kind of didn't specify what I was doing. I plug back in what u was times u prime. Now, a little bit of the nice thing with secant is that absolute value I really can't do anything with. So that's part's as simplified as it's going to go. But underneath the square root, I can do a little bit of work. So t times t, t squared, plus 2t plus 1 minus 1 is going to leave me with t squared plus 2t underneath my root. Okay. The number 4 that I have written on here, I'm not going to work through it. Know that it's a product rule. So you'd have to do derivative of the first, keep the second, keep the first. Then with your derivative of the second, you're going to use your chain rule or your derivative of the inverse trig function rules up here. But what I'm going to do is I'm going to trade this out for a problem that I definitely want to have you guys see worked out. Otherwise, many will make mistakes on this on the homework. Okay, one with a fraction involved. So my u is the 7 over x, meaning fu would be inverse sine of u. Before I take this derivative, I'm going to rewrite this as 7 times x to the negative first, just because it's a little bit easier derivative to take. Or you could do product or quotient rule. Derivative of the first, keep the second, minus blah, blah, blah. Okay. So u prime is negative 7 over x squared. Inverse sine of u is 1 over the square root of 1 minus u squared. We multiply these together. And then what was u? That was 7 over x. Okay, now with these, there's a little bit more work involved because yes, I'm letting you leave roots in the denominator. However, we cannot leave fractions inside of roots in the denominator. So start with the easy part. Squaring. I've got 1 minus, that'd be 49 over x squared. Okay. I'm going to kind of ignore this piece for right now, and I'm going to work with just the root. And I'm trying to clean this guy up so that I can do some things with it. I have 1 minus a fraction. I'm going to have to get common denominators so that I can put those two fractions together. So when I get common denominator, I have x squared over x squared minus 49 over x squared. So then I get x squared minus 49 over x squared. All of that is still underneath my root symbol. Now, if you don't remember this from Algebra 1 or 2, technically 2, not a huge ordeal, but still not touch this guy. When I take the square root of a fraction, I can actually take the square root of each piece of the fraction separately, which is a good thing because now I've got, and I'm going to come up over here, I've got the square root of x squared minus 49 over, can we take the square root of that denominator? That would be just x. Okay, not crazy pretty yet, but we're getting there. If I multiply straight across, I now have -7, and yes, you could have done this at the very beginning. Oops, that should be x squared minus 49. No, 49 minus x squared. Because now I can cancel this x in the denominator of the denominator and one of those. And that would be my final answer, -7 over x times the square root of x squared minus 49. There are a couple of problems on your homework similar to this one. Okay, I also put one on your homework where maybe you have like sine of x over 3. You don't have to go through all this derivative work. X over 3 is the same thing as 1/3 x. That's a lot easier derivative. The only time you have to do either the negative exponent or quotient rule is when the variable's in the denominator. Okay, variable in the numerator, think of it as a fraction times the variable, making your derivative easier. But as always, if you have questions, please feel free to email me and I will